my project kind of surrounded the idea of how do we actually track climate change when we only have students for 1 year? How do we start with the education, and what do we do to make sure that students understand that climate change is a long-term issue, not just we're going to learn in 1 year, we're going to see the effects in 1 year. The question and the standards that it was based off of was how do natural and human caused changes to habitat or climate impact our bell, which is our outdoor learning lab that we have. And then later on, as the project progressed, the question actually changed to how can fifth graders begin to track climate change in their school learning lab. The standards really focused around the reading, because they were reading field guides, they were pulling data from different sources and analyzing them. The science standard that was the bulk of what they were working towards was the finding evidence of natural human caused changes in habitats. And then our writing standards were the research project that they created expository essays based off of plant growth. We started out with, and I say we because this was not a solo endeavor. Miss Stephanie helped the process along. We did a lot of co-teaching lessons to build toward the learning and the background knowledge. So the first thing that we did was Miss Stephanie put together kits that included microgreens so that we could really evaluate what happens to a plant when you start to change the variables. So they learned the scientific words like variables, and they were starting to track the effects on their plants. So they looked at the elements of a habitat, things like light, the soil medium, and when they were able to add sunlight, natural sunlight to their plants. After this process, they had learned that plants need a specific set of items that were um, conducive to learning, not learning, conducive to growing. And so after that, they created expository essays where they were to gift microgreens based on their learning. They gifted the microgreens to a family or friend, and they had to write steps on how to grow successful microgreens. So here's some students. This one's a mid-level student, and this one was actually, I was really impressed with just the level of learning that was occurring, because this student is actually a student who's in our exceptional education programs, and she actually reads and writes at a second grade reading level. And so for her to really pull this together and create this essay was pretty phenomenal to see just her investment in the learning that they were doing. So based off of their learning that they had learned about the microgreens and how to successfully cultivate plants, they learned that you have to have climate, so not climate, but the sunlight and the soil health had to be a specific level in order for plants to survive. So from there, we took it into a math modeling task where we evaluated temperature change. And then I also co-taught this with another teacher who is a math teacher at our school. And students watched videos about the science behind climate change, so they understood that the effects of climate change were things like the increasing acidity in the oceans and the melting of the polar ice caps, and then also just general climate change, general increase of temperature. And so we took this graph. This is from the New York Times. And we reviewed what the change has been over time, and there were a lot of questions that this had generated from students. And one of the things that we wanted to know was, what is our future going to look like if we continue on this process? So the question was, how does global temperature rise over 10 years? And so they came up with, after looking at all of this data, they used some math modeling tasks where they evaluated in groups. They came up with math formulas to determine that their answers were all relatively the same. They said anywhere between zero point 0.8 and zero point 0.1 degrees Celsius is going to be the increase over 10 years. And then now the question becomes, how does that impact plants? How does that impact if we were to put microgreens and know that there's an increase in temperature, what are some things that we need to factor in? So we started to talk about climate change, and since I knew that this was a long-term process after looking at those graphs, oh, I did have, almost forgot. I do have some student talking, which I was really cool. Let's see. So just to kind of illustrate the learning that had occurred with it, I did have
2000,
some.
it went up to plus 1.0 degrees Celsius. So we add the rest of the chart, and it looks like every 10 years it goes up, the temperature goes up by around um, 0.2 degrees Celsius. And so in 10 years, in, well, according to this graph, since that was in 2018, um, in 10 years, we would be at, so it would be 28, and then it would be, I'm pretty sure, 1 point, plus 1.2 degrees Celsius, which is where we were in 2016.
All right. And so after we've had all of those conversations and we knew that the changes would take time, we started to talk about how could we track it in a desert environment. And so they had identified Bell as a desert environment. And we started out with doing just evaluation of the environment. So one of the things that we did was we took Google Maps and we evaluated what Bell looks like from the satellite images, and they noticed that there was a variation of the types of plants that grow within Bell. Over here to the left hand side, we actually have a water source, and so there tends to be like these larger shade trees and more lush vegetation. And then out towards this area, we have mostly creosote and cholla. And so the students were looking at them, these aerial images, and then they went inside the bell and they identified what would be the cause of the reasons why we would have it dispersed that way. And then we started to evaluate what could we do to track the health of our plants in the bell. They decided to create a field guide that could be utilized by our younger students, and on in the larger field guide. So there's actually gonna be two different field guides that are gonna be created. One is going to be a harder laminated field guide that people can just take out from the bell and walk around and identify the different plants. The other one is going to be more of a book. And in the booklet, it's going to generalize the health of the specific plants. So each of the plants have a number on them, which came from maybe 1998-ish, 97-ish. That we can use to look at the plants that they had identified at that time. And so we're going to track the same one. So for example, the saguaro is number 2, and then every year we would go out there and evaluate the health of that saguaro. Um, it would be a fifth grade project that would be continually ongoing. Students were identifying the plants using a Seek application, which is a really cool app that Miss Stephanie had brought to our attention, and they would just take, and so they started to bring their own phones and they would put it over the plants and they would grow. They would not grow. They would identify it, not grow. So after that, we were starting to dive into the species names. So we got a list of species, and we found out there were 34 different species of shrubs, cacti, and trees. And we didn't even get all of the trees. They were mainly focused on the smaller plants. They also started to talk about what were some elements of unhealthiness or not thriving plants. We saw a lot of century agave kind of just shriveled up at the base. But we looked at pictures from the bell from the previous years, and it looks similar. So maybe that's not from climate change necessarily. So they had those conversations about what could be the effects of of those plants shriveling up. And now they're just designing their Borton field guides. We're going to work on some how to create a diagram. So the learning isn't done right now. There's some really cool outcomes. Like I had one student create a time lapse video on TikTok, which was it was so beautiful because it was kind of like the last part. She just really felt like she connected to her microgreens, and for some reason it wouldn't let me insert it into the slide. So also her dream is to get 100K followers. In case any of you guys are TikTok followers. And she used it to talk specifically about how um, the plants move with the sun. And so she had illustrated that there was that movement towards the sun. And she talked about that as being an important part of the habitat. They start to use terms about weather change in their daily conversation. They would use words like climate change, heat, temperature increases, decreases. They started to become more aware of just the changes that they had saw and compare it to year after year. Um, they also began to evaluate the use of shade trees at our school. And I don't know if that was just a conversation that came up from that, but they had a lot of conversation about this would be a really great place for a tree to cause more cover, to create more a cooler environment. They also started to evaluate water usage and then talk about their disposal of water because they became very concerned about the rising temperatures. Um, the lessons learned is that this is kind of this I'm really still new to project-based learning, and so I really am trying to pull as much as I can. So I think that most of the learning came on my part on how to structure projects like this. It's almost like when Miss Stephanie and I would plan together, there was like really no end. We were like, oh, and then we could learn this and then this and then this, and there was just so much connection that was happening that I just felt like the project kept being bigger and bigger, and we just kept having the conversation of let's scale back. We got to scale. Let's look at our one little thing that we want to do because there's so much that we could do over time, and then how do we make sure that the lessons um, are easy enough for students to complete, but also have that level of challenge that it can be a continual process that moves forward. Um, don't start with the end. Don't say that this is my project and this is where I want to go. Start with your question. It takes a lot of time, and the students will always want more. Like every time there was another piece to this project that was introduced, they always wanted more. Um, and plan time for it because if you don't plan time for it, it just kind of gets lost in your curriculum. I think that this kind of became a cornerstone of a lot of the work that we're doing, and I just started connecting everything to the project. And so when the time was created in the classroom, it became a more substantial project. And then the most valuable lesson that I have learned is never try to save a bird in a cholla because it will stick to your hand. And that's it.